So, hello everyone, let's solve the same last question that I did in the last video, but now with calculus using the solution that the book gave us. Now the question we are going to solve is 2.65. Ignore this question over here, okay? If you want to try to do it after the video, it's okay. But so just find the point in this curve over here that has the minimum distance to this point here, okay? So the way the book approached it was x minus 3 squared plus y minus 6 squared. Now it would be equals 20, but he divided both sides by 20, so 20 and 20, okay? Just divided everything by 20 over here, okay? So the next thing he did was x minus 3 divided by the square root of 20 squared plus y minus 6 divided by the square root of 20 squared equals 1. I didn't do anything special. It's like I put a square root over here and put it squared, okay? So just so that I can join everything. Now if you remember from trigonometry, cosine of theta plus squared plus sine of theta squared is equal to 1, right? So this is what we are going to do. We are going to call this sine and this cosine, okay? So cosine of theta is going to be equal to x minus 3 divided by the square root of 20, okay? And sine of theta is equal to x minus 6, y minus 6 divided by the square root of 20, okay? So I hope everything is alright until here. So the only thing we did was here and here, so we changed the variable. This is like cosine squared, right? Because we have this relation. Why is this good now? Because now we are dealing with one variable, the cosine, right? The theta, the angle, okay? So what can we do now? Well, let's what does he want? He wants a distance, right? So how can we find this distance? Well, a distance is what? Is x minus the point, right? The distance is equal to the square root of x minus a point, right, squared plus y minus a point squared. Which points are these? Well, minus 2 and minus 4, okay? So minus 2 multiplied by minus will be plus 2, and here minus 4 multiplied by this minus over here will be plus 4, okay? And here squared. This formula over here it's nothing special, okay? It's the same formula for the distance from a point, a distance from 2 points, okay? If you have 2 points, right, like here you have a point here and a point here, and you want to find this distance, you make it like this, right? You make this triangle and you do the Pythagorean theorem, right? So this is what I did over here. But for the x and y's, I'm going to substitute. What am I going to substitute? Here, let's look. X is equal to square root of 20 cosine of theta plus 3. What did I do over here? This went multiplying and this summing, okay? So this will be our value of x so that we can substitute. And for the y is equal to square root of 20 sine of theta plus 6. I just send it this multiplying and this summing, okay? So now in this equation over here, in this one, we are going to put the values of x and y's in terms of cos of the angle, so that we don't need to talk about two variables but only one. So d is equal to the square root of what? X. Well, x is equal to, look, x is all this, right? And it's plus 2. Okay, so square root of 20 cosine of the angle plus, it was 3 plus this 2 over here, 5. Okay, so plus 5, and this is squared plus what? Okay, like this continues over here. Okay, so I'm going to continue over here, this part over here. So the y is what? Is the square root of 20 sine of the angle plus, now 6 plus 4, 10, right? 10 squared. So what do we need to do now? Well, take this part squared. Okay, so the d is equal to the square root of 20 will be 20 multiplied by cosine of theta squared. Now plus 2 multiplied by 5 is 10. 10 square root of 20 cosine of theta, and then plus 25. Remember, all this, let me try to write it smaller so that it all fits. Okay, so 20 cosine of theta squared plus 10 square root of cosine of theta plus 25. Now remember, all this summing the next part. Okay, so plus the next part is all this is squared, and then we're going to need to we already took the square, right? So it will only be less to take the square root. So the next thing is now taking this squared. Okay, so 20 sine of theta squared plus 2 multiplied by 10 is 20, square root of 20 sine of theta plus 10 squared is 100, and all this is we are taking the square root of all this. Okay, so don't forget about this square root over here. I'm just not writing it because I don't have the space to write it. Okay, so let's continue over here. So d is equal to, now let's sum the things that we can. So here 20 and 20, we can take them out. What do I mean by this? Like it would be 20 cosine of theta squared plus sine of theta squared. This part is 1, right? So it will be only 20. Okay, so 20, and this went out. Now the next thing, we'll have plus 10 square root of 10 cosine of theta, this plus 20 square root of, here is square root of 20, right? And here is 20 square root of 20 sine of theta plus 100 plus 25 is 125 plus 125. All this taking square root. Okay, so now it comes that we use calculus. If you want to find maximums and minimums, you derive it and equal the derivative to 0. Okay, so there's 20 over here and 125 over here. We can say that d is equal to 45 145 plus 10 square root of 20 cosine theta plus 20 square root of 20 sine theta. Okay, all this taking square root, so the derivative is equal to 1/2 multiplied by this goes down, right? Deriving the derivative of u to the half is equal to 1/2 multiplied by u to the 1/2 minus 1, right? So it will be minus 1/2. Okay, this is why it goes down. I hope it made sense. 1/2 equals, so deriving this, the simple polynomial rule, so u and minus 1, so this will be minus 1/2, so it will be 1 divided by 2 u to the minus 1/2. So okay, this is what I'm doing. Plus 20 square root of 20 sine of theta to the 1/2, which is not going to matter actually. Now above, when you derive u to the 1/2 is equal to 1/2 u to the minus 1/2 multiplied by the derivative of u, right? So the derivative of u 0, so this one 20 square root of 20, the derivative of sine of theta is cosine, and now the derivative of cosine is minus sine, so 10 square root of 20 sine of theta. Okay, so now we need to say that the comma is equal to 0. Okay, so all this will cancel because it will go multiplying, and this too. Okay, so the only thing we are going to use is this part over here. Okay, so 20 square root of 20 of cosine theta minus 10 square root of 2 sine of theta, okay, equals 0. Did it make any sense? Like, even if we put all this down here, it will go multiplying as 0, so it will cancel, so we don't need it. So 20 square root of 20 cosine theta is equal to 10 square root of 20 sine theta. Okay, went over there with a positive sign, so it will cancel, and now we have that the tangent of theta is equal to 2. Okay, so now a trick, something like you learn by doing trigonometry, is draw a triangle right like this. Okay, so call this the angle theta. Okay, so the tangent of theta is 2, but what is the tangent? Is the opposite divided by the side. Why did I choose 1 over here? Because, well, tangent of theta is equal to the opposite, which is 2, divided by 1, which is 2. Okay, so this is what he's telling us. So what would be this side over here? Well, x squared is equal to 4 plus 1, right? This squared plus this squared, like the Pythagorean theorem. So x is going to be square root of 5. So here's 5. So now we can find that cosine of theta is equal what? To the side divided by square root of 5, and sine of theta is equal to what? The opposite divided by the hypotenuse, right? So 2 divided by square root of 5. Yeah. So how, remember, what is this point that we just found for the cosine for the cosine and sine? Well, they are the points of maximum and minimum, but remember that we know a relation between sine and cosine. Well, this relation over here for cosine, so we can find the x's and the y's that gives us the points of maximum and minimums in terms of x's and y's. Okay, so let's just copy this. Okay, and let's go over here. Okay, so now let's put the value of our x. So x will be square root of 20. Cosine of theta is equal to square root of 5 plus 3. Okay, so this square root of 20, remember 20 is 4 multiplied by 5, so it is equal to 2 square root of 5, which is going to cancel with this square root. Okay, so x is going to be 2 plus 3 is going to be 5. Okay, and now there is another value for x. Okay, but let's just find the value of y over here. Here. So y is equal to this, right? So, and remember the value of the sine, we found it, 2 square root of 5. What? This was 6 over here. This was 6. I don't know how. What? So y is equal to, well, the same thing. The square root of 20 is equal to what? To 2 multiplied by the square root of 5. Sine of theta is equal to 2 divided by square root of 5 plus 6. So y is equal to 4, right? Because here cancels. 2 multiplied by 2 is 4 plus 6 is 10. So y is equal to 10. So is this our answer? Now, is this our answer? So is our answer, is this our answer? Is our answer 5 and 10? It's not, okay, because there is a point that is new. So why this is not the point? Like, it seems that we did everything right? So we substitute, remember, we substitute this by cosine, this by sine, so that we can have a nice relation. We did the formula for a distance from 2 points, and then we substitute our x's and our y's so that we have only one variable. We had a function, we derived it, and we equal it to 0 so that we can have the maximum and minimums. Well, the part that is wrong is over here in our trick. Why is that? Because look, the tangent of theta is equal to what? The sine divided by the cosine of theta, right? So if both of them were negative, then the tangent will still be positive. What do I mean by this? Well, in the trick that I used to call this 2 and 1s, here they were length, so they had to be positive, but it doesn't need to be this way in tangent and in the tangent of an angle, because if it was like minus 2 divided by minus 1, it will still be 2, right? So it could be that this was minus 2 and this was minus 1. I know that it doesn't make any sense when we are talking about length, but do you understand that the tangent is sine divided by a cosine? So what we chose was that the tangent is 2 divided by 1, but it could be minus 2 divided by minus 1, okay? So keep this in mind. So another values that are possible for the cosine of theta is equal to minus 1 divided by square root of 5, and for the sine of theta is equal to minus 2 divided by the square root of 5. Do you want to test it? Look, tangent of theta is equal to what? Sine of theta divided by the cosine, right? So let's divide them. Well, it's going to be multiplied to the inverse, right? Divided by 1. So this will cut with this, the negative will cut with negative, and we will end up having only 2, okay? So this is why it works, okay? So both these values are both correct, okay? So the problem was in this trick that I used. This trick gave us only one value of the tangent, okay? This trick over here. So now we have this second possibility. Now let me just take the values of our here. So now we are going to do the same thing, and then we are going to see which, if this point over here is the point that is near, or if using these cosines it will have a nearer point. Okay, so let's use these values. So for x is equal to square root of 20 is 2 square root of 5 multiplied by cosine of theta. Now we are going to use minus 1 divided by square root of 5. So minus 1 divided by square root of 5 plus 3. So this will cut, and we'll have that minus 2 plus 3 is 1. Okay, so x is equal to 1. Now for the y part, so y is equal to square root of 20 is 2 square root of 5. Sine of theta is equal to what? Minus 2 square root of 5. Okay, minus 2 square root of 5 plus 6. So this will cut, this will cut, so we'll have 6 minus 4, so the y is equal to 2. So this point we have over here is 1 and 2. Okay, now how can we check which points that is better? Remember, we found 2 points, 5 and 10 over there. So how can we know which one is better, 5 and 10 or 2 and 1? Well, you can imagine it by drawing like the circle. Well, the circle had a center in 3 and 6, and it had a square root of 20. Okay, so the circle was over here, 3 and 6. Okay, so, and the point that he wants us to see the distance what over here, which is minus 2 and minus 4, right? So minus 2 and minus 4. So you can see which one seems closer, 1 and 2 or 5 and 10. You see the line over here? So, and you can absolutely do the distance between 2 points. You have that your question is minus 2 minus 4. So the distance between these 2 points, you can find the distance between this point and this point and this. Okay, and you will see that the distance between this and this one is the smallest, or by looking just to the photo, by drawing a little drawing. So the answer is again 1 and 2. Okay, so